Swayam Prabha. Digital India. Educated India.
Hello everyone. Today we will discuss about life cycle analysis. So, what is a life cycle analysis? So, life cycle analysis is actually a process through which we analyze life of any product. So, what do we mean by life? For example, any living organism, any living being, it gets a birth one day, and it lives its life. It consumes resources. It releases some excretions and things, and then it dies one day, and it goes it gets disintegrated, it gets decomposed, it goes back to the nature only. So similarly, any product what we design today or we manufacture today, okay, so any project which we execute today, any a developmental project, anything, so that also gets its life one day. It runs for its a usable a lifetime, and then it gets discarded once the age of its a usability actually gets over. So at that time it goes for the dismantling, decomposition, degradation, or whatever, depending upon its molecular or materialistic material properties and things. It gets it comes to the end of its a life cycle. So that is actually entirely the basis of the very generic actually understanding of the life cycle analysis is. So let's see this actually illustration over here. This talks about kind of an interrelationship between a different activities, and it talks about the interrelationship from outside its limit also. So if you see the first one, for any such product, there must be a goal, there must be some actually scope and usability of it. So based on that, it will go for the inventory analysis. Based on that, it will go for the impact assessment. And meanwhile, while carrying out actually all of these activities, it will keep on actually corresponding. It will keep on actually interacting with the other entities, other stakeholders also. And as a direct application, as a direct impact of it, okay, it produces actually some sorts of it satisfies actually some functions, it fulfills actually some functions, it fulfills its a purpose, it exerts actually some kind of impact. So those are the actually things which we list under these direct applications. So for example, the product development, strategical plans, public policy planning, marketing, etc. So it will be more clearer in this actually illustration over here if you see. So this red boundary, this red dotted line is the system boundary, okay, of that actually particular for example the product. So within that boundary, it actually acquires, it actually sources the raw material, it goes for the manufacturing processes, it takes up actually the fabrication facility, and in any sort of construction, or the manufacturing, or all of the, including all varieties, whatever is needed actually for that particular item. Then it goes for it's a usable life, it goes for a reusability, and then it goes for even a normal maintenance, depending upon the requirement. For example, any building, so once constructed, okay, we keep on actually maintaining it, we keep on actually repairing it for any sorts of faults which are coming up in in its functionality, and it's a structure, or in any of its component, whether it is building services related things or anything. And then it goes for at the end of its a life cycle, it goes for recycling, it goes for the waste management, and those activities, the end of the life stage actually activities. So out of this boundary, actually how these things actually take place, they actually it takes actually a lot of resources from the outside. So in the form of the raw material, or even a finished product, okay, and it form of the energy. So the energy is also one of the very important actually inputs what it receives, and in turn as a output, what it gives is the atmospheric emissions, for example all sorts of CO2s and other GHG gases. Okay, and then it gives even a water based pollutants like effluents, etc. Then it discharges actually like a solid waste also, it gives as a solid waste also, some a metal based actually by some waste, or maybe some chemical compound waste based, or maybe some even organic actually compound organic material based actually waste. So any sorts of gaseous, liquid, or a solid waste. Then it gives a co-products also, a byproducts also. It gives all sorts of other these things also. And then there are some other releases also, as in the form of the other forms of energy. Okay, so there are some inputs, there are the main component, the main body of it, and then there are some outputs also. So this is actually entirely kind of encompasses the overall life of any product. So for example, we see our mobile phones. So our mobile phones actually utilize different sorts of metals. They utilize plastics. So it uses actually a lot of the resources. It consumes actually the n number of a material, and then it exerts actually some kind of impact. Let's understand this from this next actually slide over here. So in the input area, if you see for the consumption, as a consumption material for the that unit over here. So there are things like energy is one of the major components utilized for as a resource, an input resource material, in the form of a direct electricity, or in the form of a crude oil, natural gases, so these are all actually forms of energy, they are required actually for generating energy. Then it is required for mineral resources, such as iron ore, different other types of mineral based actually materials, ore based actually materials, for bauxite is for aluminum industry, and things like that. Then there are renewable resources which are also required up to a certain extent, such as water, air, sometimes a timber, wood, etc. So these are actually renewable resources, nature based resources which are finite in number. So these are also required for actually as a input material. Then it goes for actually processing, goes for extraction, the manufacturing. It goes for the processing part of it. Then it goes for a transportation from one place to another, transportation of the raw material, then transportation of the finished material. Then it goes for the uses part. Okay, so the uses actually is the major part where the end user actually interacts with the product, consumes that actually product, or lives with it. And it in turn actually for depending upon the product, it provides the maintenance, it provides the energy, it provides the repair, and it provides the other consumption, consuming materials as a raw materials for that product. For example, if an automobile is there, then it requires constantly the if it is a hydrocarbon based engine, then it requires hydrocarbons to keep running. So those kind of raw materials are also the input materials are also needed for the main product, okay, which we are actually analyzing. Then at the end of the life stage, it goes for the disposal and recycling. So in the nutshell, this is the overall actually a philosophy behind a LCA, life cycle analysis. And as an output is releases it releases actually a number of gases and liquid effluents, then solid effluents, and solid waste material, and things like that. And there actually if we compare with the environmental impact assessment, so there are actually some sorts of impacts on all of these actually three the stages of the LCA, if you see. So if you see on the bottom left side portion, so from there it starts exerting its impact. For example, if we are actually extracting natural resources, if you are extracting hydrocarbons, if you are actually extracting other wood, timber, and if you are harvesting trees, etc. So there are actually some kind of impact we are exerting on the ecosystem. And while it's a usage in its a main lifetime period, if you are consuming even more resources, for example, I gave the example of automobile. So there also it's exerting actually impact. Okay, and on the like a wastage part, if it's like a discarded, then how it's going to like gets disposed in the like a nature. So whether there is like any like a recycling facility available to take care of this like a waste product completely, or it's going to like generate some impact of, through like it's like a the wasted material, or through its entire like a functional life it keeps on actually emitting like a gases. Okay, SOx, NOx gases and several other types of like gases. Okay, so they are all actually the kind of the outputs of the waste material or the discharges which a product actually releases over its like a lifetime. And in turn, well, we are all aware of the other like impacts which are happening at the like a global level. For example, like acid rains, for example, like a global warming itself. Okay, and the depletion of resources, the contamination of like a natural resources such as air, water and earth. Okay, noise pollution, light pollution. So all of these actually sorts of things actually take place in and around a life cycle of a product. So the intent of actually this course over here is to make you aware of like how these actually impacts at the different life stages can be actually handled. So we will see some of the like case studies, some of the actually life cycle analysis of the different types of the products and materials. Okay, to understand the overall like a mechanism, like how it functions over the time. So why do we need actually LCA? So there are actually simple reasons. The first one is to identify the opportunity areas to improve the environmental performance of that particular product, because we clearly saw like the impacts are possible at any stages of the product life cycle. So we must actually be aware of actually what are those impacts and how these are actually taking place, so that we can minimize it, we can actually get rid of it if it is possible completely. So we can at least work on it. The second is to like take like informed decisions. So taking informed decisions is also like a very important actually factor, because if some sort of like repercussions come up later, or some form of like a discovery actually takes place later in the life cycle of any product, then actually there will be like a very bad actually repercussions and after effects. So we must actually take or undertake actually these LCA etc. for any like a product, any like a newly proposed product, to understand and rectify the possible actually damages, possible like impacts this product can cause in its entire life cycle, and accordingly we can take like an informed decision. Like as we like discuss in the EIA actually lecture, environmental impact assessment chapter. So environmental impact assessments and these like LCA and these actually studies are actually meant for actually taking corrective measures, meant for actually informed decision making actually processes, so that the overall process can be improved upon. Next one, like it helps in selecting like relevant indicators of like environmental performance. And lastly, well, it helps even devising like a certain sorts of a certain like a types of like a marketing strategies. For example, like a eco label is given over here. So eco label is actually marketing strategy, so which actually advertises the responsible actually products which have been actually produced, which have been actually properly actually taken care of through the like a EIA and LCA sorts of like a analysis, and they are actually the result of the like the analysis of actually such like studies, and they are actually labeled as like a eco label actually products. So they carry actually some like a optimum level of actually responsible like behavior towards the ecology, and they are considered to be one of the good ones compared to the other like normal products available in the market, because they exert like a comparatively like a lesser impact than the generic like products. So such actually decisions can be actually taken care of with the help of a like a analysis such as like a LCA. Well, there are some limitations also of LCA. Let's see what are these limitations. So, well, LCA gives like a some glimpse of the life cycle of a product, but it's not actually complete assessment of like all environmental issues. Well, it doesn't talks about actually social issues. For example, it doesn't talks about actually economical issues also of any like a product. Okay, so there are some actually limitations for LCA, and we must actually understand those limitations also, so that we can take the informed decision properly. Well, LCA we can rarely and if ever includes like every single process and capture like every single input and output due to like a system boundaries, data gaps, and cutoff criteria. So there could be some limitations while actually undertaking that study itself, whether the like a system boundary is like a defined, whether it is like a known, all of the data is available, whether the data is available in the like a quantifiable format, because LCA actually analyze on the like a quantifiable format only. So if there is some data which is subjective in nature, that cannot be actually processed under like a LCA. Yeah, and there are some other like issues, such as like a sensitivity issues, some like a value system based issues, or some like maybe culture based issues. So those actually sorts of like issues cannot be actually taken care of by like a LCA. So these are actually limitations. So let's move to the like a system boundary and try understanding the LCA process. So the product being analyzed, the hierarchy of inputs and the level of detail in the life cycle all go to define the system boundary. So as it talks over here, the details in the like a life cycle like a analysis. So for example, what are its like a reaches, what are the different like stakeholders, what are the activities happening between the different stakeholders, how it is behaving. So all of this actually in a combined way, it becomes actually a system boundary for conducting like a LCA. Let's see this illustration over here. It gives an idea of like how a typical actually there are the typical actually stages inside like a life cycle analysis of like any product. So you can see from here it starts with the process of like a resource extraction and processing, and it goes on with the like a design, then it goes for the manufacturing and retailing, then it goes for like a distribution, then it goes for the like a use, then it goes for like a once the end of life actually happens, then it goes for the like a collection back, or it goes for like a reuse, recycling, energy recovery, or disposal, or even like a till the like a if it is a landing in the like a landfills, if it is like a discarded in the simple like a outside like our premises. So all of those things. So if you see, so from source till the like a manufacturing, it is known as like a cradle to gate. So this is being the cradle from where it is getting actually it's like a at it's like a, at a elemental level from where we are actually starting to source these materials. For example, if it is like a mineral ore, then the ore actually is the actually cradle of that metal which we are going to extract from actually that ore. So from these ore like a mines to like this manufacturing unit, this becomes like a cradle to gate, and from actually this place to like the place of its distribution, it becomes like a till the cradle to site. Then from cradle to grave, one it is like recycled or reused or disposed of, and if it in its elemental form, it starts from here, it lives its life, it dies, and if it comes back to again to its elemental form, that is actually that concept we know it as like a cradle to cradle. For example, if any like a natural like a living being actually dies, for example any like an animal, or maybe even if like a tree actually dies, it just falls in the like a forest, and then it starts actually deteriorating and disintegrating, and over actually period of time, maybe in a year or two, and like a 5-10 years, it will vanish completely. So mammoth actually structure such as like a tree also is able to disintegrate and decompose into like a such a like a at a elemental actually level that you cannot found the traces of it once it is gone. So that is actually a concept of cradle to cradle. So from wherever it started, from like a seed in the like a soil, and then it germinated into a big tree, and then it lives its life, it died, and then it goes back again to the soil. So that is actually concept of like a cradle to cradle. But if a man-made product, if a human-made product, if it is not reaching its cradle to cradle again after the uses, then there is the problem, and this is the actually problem of pollution which is happening. The resources are lying at the wrong places, and that is causing the whole this phenomena of pollution. So let's try understanding these LCA concept actually through different case studies over here. So I have actually gathered a number of case studies from a different actually manufacturing units, different actually product types. So we will try understanding it. So here the example is actually for actually a laundry, actually the cloth actually washing actually activity. So here if you see the 75% of energy during laundry cycle, laundry life cycle is consumed in the in uses phase. So while it is being used at the at the user facility, so this is the place where it consumes like a 75% of the energy of its entire life cycle. So if you see it starts from the supplier, go to a transport, manufacturing, packaging, then uses, then disposal. So this is the typical life cycle of a laundry. So this is the place where it consumes the highest. So what is the learning from this slide over here? This use phase a stage is a stage which consumes 75% of energy. So is there a way to minimize actually this volume of energy which is actually consumed by this unit? So we can work on actually improving the efficiency of it, because this product, this appliance is going to be there for a number of years, a good number of years, minimum a 10 years. I think we can say a general a household washing machine or a laundry unit actually lasts 10 to 15 years. So 10 to 15 years for a product appliance is a long period of time, and it's going to consume a huge volume of energy, even if it is used maybe once per 2 days or so. So how this energy consumption can be reduced? So this could be the actually potential actually intervention area for you and me as a designer, architect, and engineer to work on it and create that the impression, create that actually lasting actually effort for actually minimizing the energy consumption part. So this energy consumption on the usage basis becomes the actually focus in such products. So this is the learning from here. We should actually conduct this LCA, because this LCA actually gives us this analogy how much of embodied energy, how much of the usage energy, how much of the at the end of the life cycle stage is going to create some kind of impact. For example, resource consumption, energy consumption, etc., etc. So let's see for the next example over here for a life cycle of steel. So if we see steel is such a material which has become the backbone of our today's growth and development actually activity. Without steel actually nothing is possible. If you see electricity generation, so all our tools, equipments, all our transportation sector tools and equipments, all our machineries, all our even electronic gadgets in our buildings, almost every material, starting from a small needle to the aeroplane till the biggest manufacturing units, from the hydrocarbon rigs, every machinery, every equipment actually uses some form of the steel. So steel is the actually in the recent actually years has gained the most prominent, if we go by the metal actually sheet. So steel is one of the best actually materials, very helpful materials, which is not very costly, and it offers plenty of workability. It offers actually machinability. It is adaptable, it is ductile, it is malleable, it is it can be drawn into shaped into n number of shapes and volumes and structures. It can be casted into any forms we want. So all our combustion engines of the automobiles are also casted into steel based alloys and different using a different other metal also for its rigidity and strength. So there are n number of uses. If you look around your space right now, you will see n number of applications of steel. So how the life cycle of a steel actually looks like? So this is actually a schematic diagram which talks about it starts from the extraction of the raw material, extraction of the ore from the mines. There are iron actually mines, steel mines in the different places, like in our country, like states of like Chhattisgarh and Jharkhand, they are the actually major, and Odisha are the actually major supplier of like a steel based actually iron ores and minerals. And from there it goes for the like a production unit. From there actually they take out the metal part from that ore, and they actually start actually sending it for like a fabrication and manufacturing, for depending upon the requirement of the like tools and equipments and whatever we actually need for. Then it goes for like the uses various. For example, you can see over here the uses of steel in like a upgrading, uses of steel in like even like a energy harvesting like units. For example, windmill is given over there. Then it goes for like a automobile. All of those are like applications actually in different application it goes for. Then it comes back again for like a reusability, for its remanufacturing or repurposing, because steel is a very highly recyclable material. Okay, steel is one of the materials which any scrap dealer, any scrap actually buyer will pay you for, and you can give it to him, and it will again, that piece of that scrap will come back to the factory, and again it will go and get melt, and it will again become a part of the some machine or some equipment. So steel is such a material which you can recycle for like a n number of times. You can keep it like a recycling for like a longer like a number of times. You can keep on like a purifying it also in the smelting and the melting processes. So it offers actually a lot of like a flexibility in terms of these sustainability parameters, that we can keep on recycling this metal as like a for a very long period of time. So the recovery actually efficiency in from like this steel is like very high, and steel is always like there is like some price, some good price you can get in the market. So it actually encourages the household people also to sell any like a equipment, any like a product which has like some steel component to the scrap dealer, and they get actually some value paid in turn. So it helps actually, this actually this resellability, this recovery actually capacity, this recovery efficiency actually helps in actually increasing the recycling, increasing the actually potential for the recycling. And even if it goes it's discarded in the like a nature, if it goes in the landfills, so what happens, it with the like exposure to the air, exposure to the water and moisture, it starts actually oxidizing, and then it starts breaking in its like a elemental form, and it goes back again into the nature in its elemental form, and maybe again it can be recollected someday and can be put to use. So steel actually offers like a lot of flexibility, and steel directly doesn't have actually any like bad impacts during its like a usage period. There are emissions, extreme like a volume of emissions actually come out while processing it. So that is one of the actually disadvantages. But with all of these disadvantages, it offers a huge volume of actually opportunity and usability also, and that is why actually steel is one of the actually most usable actually metals of this time. So let's see like how this gets like a recycled. So this illustration actually gives a clear picture of the recycling part of only of like steel. So once it gets in the system from like its raw material extraction etc., then it goes for the steel production, then it goes for like a usage, then it comes back as a like a scrap. Okay, then again it goes as a scrap in the like a steel production, it gets refurbished and kind of recasted into a new product itself. Then again it goes for the like it's usable like usability, it's like a uses, and it again lasts there for like several years, and then again it goes for the recycling, then again it comes to the factory. So this is how actually the cycle of the steel as a like a metal, as a material, keeps on actually running. So steel is one of the best materials for as far as like a recycling process is concerned. But there are some actually considerations. For example, if we maintain the purity of the material, if we do not make it like for example, like we discussed in the previous lectures, the alloys actually offer very high strength, very high actually the usability Okay, they can be used actually in a very like a high stressful or a tensile actually requirements, places of requirements such as like avionics and all. But in the general life, for example, normal like a two-wheeler which is not going to exceed a speed of like 100 kilometers like a per hour. So there may not be any like a particular need to use actually such like a complex composites and alloys, because at the time of the disposal of that actually motorbike, it's going to be really tough to actually take out those different actually materials, those metals from the alloy, and again reuse them. So alloys are at the time of their uses, they offer actually immense like strength and power, but at the same time in the at the time of their disposal they become actually very difficult to recycle also. So we must take actually such decisions with the full actually this consciousness, like what kind of applications are actually desired through that actually product. Let's go to the next this case example over here. So this talks about buildings like a whole life like emissions. So the focus over here is on the emissions. So starting from the it's like a extraction from the top, like a green component you can see over here, that is the starting point. So we extract actually these in the form of the like raw materials, different actually materials which are needed for the building. Well, building consumes like a n number of like a materials and types of like a materials. Okay, all sorts of material including steel, cement, stone, and the PVCs and the metals and wood, timber, plastics, glasses. So all sorts of materials are actually have actually found places somewhere in the like a building industry. Then it goes for the manufacturing actually units. It gets manufactured in the respective actually products. Then it goes for the transportation to the site. It goes for the the real execution of that building. Then once the building is completed, the building goes for the occupation, and the main operational actually phase starts, and it takes like a longer period of time. So our normal buildings like a lifetime actually ranges from like a 30 to 120 years. So depending upon actually the application and the strength of the materials actually used in the construction of that building. So after this actually extensive actually period of time, it goes for its end of the life, and before that actually it keeps on carrying its like a maintenance and retrofitting and other like repair activities also. Then the operation actually stays ends, and then it goes for like a demolition and deconstruction. At the stage of the demolition actually that rebel material, they are actually taken away from the site for like a extraction, and some of the bulk actually the concrete part, the grit and cement part, sand part actually goes for like a landfills, because till now there are no actually efficient on the economics actually parameter like systems available to recover actually the concrete part. So there are still like some researches and experimentations going on to deal with that, but the extracted actually metal parts and other like a components such as like a glass, etc., they go for actually recycling, and this is how actually a building the components of the building come to an end. So during this period, you see that the embodied emissions, they range from like 20 to 50% of a building's like a whole life like emissions. So this is this arrow mark you can see over, you can understand over there. So that is the kind of impact building a normal building actually exerts. So like how it goes, you see this illustration over here. So a new building actually comes up, it goes comes up with like a concept stage, then it goes for like a design, construction, then in the blue actually shaded area, if you see, it goes for like a sale, leasing, it goes for like uses by this like the occupants, then it goes for like its repair, maintenance, serviceability and all the retrofitting, etc. Then again goes for the deconstruction or demolition, and then again this is how actually the life cycle of a building actually occurs usually. So we will see that the LCF like just a construction project in detail over here. So you see that the product in the name of the like a product, so raw material supply, transportation, manufacturing takes place. Then it goes for the construction phase, so distribution, transportation, construction, new and like a renovation, etc. Also like whether it is a new building or a renovation of like an old building. Okay, installation, several sorts of like installations actually take place. Then in the usage period, actually the use of the products installed, and the maintenance, repair, replacement, refurbishment. So these are actually finer activities which take place during a period of like a lifetime of a building, and at the end of the life it goes for like a demolition, reusing, recycling, disposal as a waste material. So this is how actually it goes to an end. Okay, how does a vehicle actually fares on the like a LCA like a parameter? So if you see like a LCA based vehicle emissions regulatory focus. So in this one, well, it goes for like a raw material extraction, the material and the powertrain and components manufacturing of that actually vehicle. Then it goes for the final vehicle is like a manufacturer, because any vehicle manufacturing company, it is likely that they may not be producing all components or all parts of that automobile, and they may be taking actually help of several other like a sub manufacturers and subcontractors who supply actually the components and parts of those that automobile.